In 1 billion years, our world will be unrecognizable. This is a span of time so vast it defies our everyday comprehension. It is 1,000 million years, long enough to sculpt mountains from flat plains, swallow coastlines beneath new oceans. To contemplate such a future is to look upon the very machinery of the cosmos and our planet's place within it. It forces us to ask a profound question: what will our Earth become? The answer, woven from the slow, inexorable forces of astronomy and geology, is a story of immense power, endings, astonishing new beginnings. This question matters, not because any of us will be here to witness it, but because it gives us a vital perspective. It reveals the immense, slow-moving currents of change that have always governed our planet. These are the same forces that created the world we know today, the ones that lifted the Himalayas, carved the Grand Canyon. Understanding this grand planetary narrative helps us see our own time, our own impact with greater clarity. It is a story about the sun, our life-giving star. It is a story about the very ground beneath our feet. It is a story about the incredible resilience of life itself, which has clung to this rocky sphere through epochs of unimaginable transformation. The tale of Earth's distant future is not one of sudden, explosive catastrophe. It is instead a story of gradual, relentless alteration, like watching a glacier move, a process so slow as to be invisible day to day, yet possessing the power to reshape an entire landscape over millennia. The story begins 93 million miles away with our sun. It is the engine of our world, the source of all energy, light, and warmth. But this star, like all stars, is not static. It is aging. Deep within its core, a furious nuclear reaction fuses hydrogen atoms into helium, releasing the tremendous energy that bathes our planet. As the sun consumes its hydrogen fuel, its core gradually contracts and heats up. This in turn causes the sun's outer layers to burn more fiercely. The result is a slow, almost imperceptible increase in its brightness and heat output, a change of just a fraction of a percent every 100 million years. Yet over the immense timescale of 1 billion years, its consequences are monumental. By the time 1 billion years have passed, our sun will be approximately 10% brighter than it is today. This may not sound like a dramatic increase, but for a planet as delicately balanced as Earth, it is a colossal shift. This additional energy will pour down upon the atmosphere, the oceans, and the land, initiating a fundamental change in the global climate system. It is a slow-turning celestial dial, raising the planet's temperature degree by degree over countless generations. This is not a change caused by us, but a cosmic inevitability, a chapter in the sun's own life story that will profoundly rewrite the future of our world and every living thing upon it. The most immediate effect of this solar brightening will be a rise in global temperatures. The delicate equilibrium that has allowed complex life to flourish will be pushed into a new, hotter state. This is not simply a matter of warmer summer days. It is a permanent shift in the planet's energy budget. The polar ice caps, ancient reservoirs of frozen water, will be unable to withstand this persistent warmth. They will melt, releasing their water into the seas. Glaciers that have clung to the world's highest mountains for millions of years will vanish completely, altering river systems that depend on their seasonal meltwater for survival. The Earth will become a far hotter place. This relentless heating will trigger a powerful feedback loop involving the oceans. As the surface of the sea warms, more water evaporates into the atmosphere. Water vapor is a potent greenhouse gas, far more effective at trapping heat than carbon dioxide. So, a hotter sun leads to more water vapor, which in turn traps more of the sun's heat, further accelerating the warming of the planet. Scientists call this a moist greenhouse effect, a tipping point from which the climate cannot easily return. A one-way path toward a world where the oceans themselves begin to slowly, inexorably, boil away into space, starting from the upper atmosphere. While the sun dictates the climate from above, an equally powerful force will be reshaping the world from below. The Earth's crust is not a single, solid shell. It is a mosaic of gigantic tectonic plates, which float upon the molten rock of the mantle beneath. These plates are in constant slow-motion conflict, crashing together, pulling apart, sliding past one another. This geological dance moves at the speed at which a fingernail grows, and it drives earthquakes, and it drives volcanoes. Over 1 billion years, this movement can completely rearrange the map of the world, creating landscapes utterly alien to us. Geologists who model these movements predict the continents are on a collision course. North America may smash into a northward drifting Antarctica. South America may smash into a northward drifting Antarctica. Antarctica drifts northward. Africa continues its slow-motion crunch. Eurasia continues its slow-motion crunch. The likely outcome over hundreds of millions of years is a new supercontinent. Amasia, Pangaea Ultima. All Earth's major landmasses fused into a single colossal block, surrounded by a vast global ocean. That formation would devastate climate and life. The interior of this supercontinent would be an immense, unimaginably arid desert. Far from the oceans, the heartland would experience extreme temperatures. Scorching summers, frigid winters. Rain-bearing clouds would rarely reach the deep interior, leaving a desolate, wind-scoured wasteland. Coastlines would be battered by ferocious weather systems, borne over the uninterrupted sea. The world would become two extremes: a single gigantic ocean and a single gigantic, mostly inhospitable continent. Meanwhile, the melting of all terrestrial ice will raise sea levels dramatically. Coastlines as we know them will cease to exist. Florida submerged, Bangladesh submerged, the Netherlands submerged. Entire cities will be lost, entire cultures will be lost, entire ecosystems will be lost. New coastlines will be carved along the edges of today's inland mountain ranges. Rising water plus new continental arrangement will reshape Earth until it barely resembles the world we know. In the far future, a brighter sun and rearranged continents drive extreme environmental pressure. The great tapestry of biodiversity begins to unravel. Forests thin, reefs bleach, webs of life fray. Plants falter as temperatures soar and water vanishes. Heat shimmers over cracked basins and withered canopies. At the leaf scale, stomata strain. Photosynthesis stalls as carbon dioxide dwindles over millions of years. Animals that depend on plants follow into decline. Large, warm-blooded species suffer first under relentless heat. Only the most adaptable endure. Small, nocturnal, burrowing, clinging to scattered havens at polar coasts, in caves, in abyssal trenches. Ultimately, the survivors that thrive are simplest, microbes and extremophiles feeding on chemistry, not sunlight. Soft. Even as empires of complexity fade, life adapts and endures, in humbler forms on an austere, resilient Earth. The fate of life is not just tied to heat and geography. It is also dependent on the very chemistry of the planet. The air we breathe, the water we drink, and the invisible magnetic shield that protects us are all subject to profound, long-term change. As the Earth warms, the composition of the atmosphere will be fundamentally altered. The moist greenhouse effect will saturate the lower atmosphere with water vapor. High in the stratosphere, intense ultraviolet radiation from the brighter sun will break these water molecules apart. The lighter hydrogen atoms will then be able to escape Earth's gravity and bleed away into space, forever lost to the planet. This slow loss of water is a critical turning point. It marks the beginning of the end for Earth's oceans. Over hundreds of millions of years, this process will gradually desiccate the planet, turning our blue marble into a dry, barren world, much like Venus is today. The oceans, which have nurtured life for nearly 4 billion years, will slowly evaporate, leaving behind vast salt flats where teeming reefs and abyssal plains once lay. Without liquid water on the surface, the conditions for life as we know it become impossible. This is the ultimate long-term consequence of the sun's brightening, the slow, inexorable sterilization of the planet's surface. Another vital element of our planet is its magnetic field. Generated by the swirling liquid iron in the outer core, this invisible shield deflects the solar wind, a constant stream of charged particles flowing from the sun. Without it, these particles would strip away our atmosphere over geological time. However, the Earth's core is slowly cooling. In a billion years, it's possible that the outer core could solidify to a point where the dynamo that generates the magnetic field sputters and dies. The loss of this shield would leave the atmosphere vulnerable, accelerating the loss of water and exposing any remaining surface life to harmful cosmic radiation. The balance of gases in the atmosphere will also shift dramatically. Over millions of years, geological processes like the weathering of silicate rocks naturally remove carbon dioxide from the atmosphere. While this has historically helped to regulate the planet's temperature, in the far future, it becomes a problem for life. Photosynthesis requires carbon dioxide. As CO2 levels drop below a critical threshold, plants will no longer be able to survive. Scientists estimate this could happen within 600 to 900 million years. The air itself, once a source of life, will become a barrier to it, starving the very producers upon which the entire food web depends. Amidst this epic of planetary transformation, where do we, humanity, fit in? A billion years is an almost unimaginably long time for a species like ours. Modern humans have existed for only a few 100,000 years, and our technological civilization is barely a few centuries old. Projecting our existence across a timescale more than 1,000 times longer than our evolutionary history is an exercise in profound humility. The challenges our species would face, environmental, evolutionary, and even existential, are staggering. Survival is by no means guaranteed. In fact, it is deeply improbable. If humanity or some descendant species were to survive, it would require a level of technological mastery and long-term planning that is currently beyond our grasp. We would need to become true stewards of the planet, engineering the climate on a global scale to counteract the sun's increasing luminosity. This might involve constructing colossal sunshades in space, or finding ways to manage the atmospheric chemistry to maintain a habitable temperature. We would have to migrate our populations toward the cooling polar regions, migrate our agriculture toward the poles, abandoning the scorched equatorial lands. Ultimately, however, an earthbound existence would become untenable. The planet itself is on a collision course with uninhabitability. The only long-term path to survival for our lineage would be to leave our homeworld behind. Becoming a multi-planetary and eventually interstellar species may be the only way to outlast the slow death of our planet. This would mean establishing self-sustaining colonies on Mars, the moons of Jupiter and Saturn, or eventually on planets orbiting other stars. This is a leap far beyond anything we can currently achieve, requiring breakthroughs in science and engineering that are, for now, the stuff of science fiction. But it is also possible, perhaps even likely, that humanity will not be there to witness this distant future. Our species could succumb to any number of threats long before the sun makes Earth uninhabitable. Self-inflicted disasters, pandemics, or the simple, unguided process of evolution could lead to our extinction or our transformation into something no longer recognizable as human. In the grand billion-year story of Earth, we may be just a brief, brilliant flash, a fleeting moment of consciousness that arose, gazed at the stars, and then vanished back into the geological dust from which it came. Our ultimate legacy remains unwritten. As we pull back and look upon this distant future, a clear, if sobering picture emerges. In 1 billion years, Earth will be a planet returning to its primordial state. It will be hot, dry, and largely hostile to the complex, multicellular life that defines our current era. The sun, our giver of life, will become its taker. The continents, whose steady drift gave rise to our varied world, will crush together into a desolate monolith. The oceans, the cradle of all life, will slowly turn to vapor and be lost to the cosmos. This is the planet's destiny, written in the laws of physics and the slow grinding mechanics of geology. This journey into the deep future provides a powerful, humbling perspective. It shows that our world, which seems so permanent and stable, is in fact a transient and ever-changing place. The forces that will one day render it uninhabitable are the very same forces that made it habitable in the first place. The sun's stable energy, the movement of the plates, the presence of liquid water, all are temporary conditions in the life of a planet. This perspective doesn't diminish the beauty and wonder of our world. It enhances it, casting our present moment as an exceptionally precious gift, a fleeting spring in the planet's long year. The single, undeniable conclusion is that change is the only constant. Life on Earth has always existed in a dynamic dance with its environment, and that dance will continue. While the world of large animals and lush forests may be doomed, life itself will likely endure in simpler forms, hidden away in the planet's last refuges. The story of Earth is not just our story, it is the story of 4 billion years of life's resilience. And that resilience suggests that the final chapter has not yet been written. Even on a scorched and fading world, the spark of life may hold on, waiting for its next opportunity, however and wherever that may be. And so, this vision of 1 billion years from now leaves us with a question, not about the distant future, but about today. Knowing that our time on this vibrant blue-green world is finite, and seeing the immense creative power of the life it holds, we must ask ourselves, how then shall we live?